Hello guys, and welcome back to Getting Good with JavaScript. This is the third screencast in the series, and we're going to cover the information talked about in chapter 3 in this book. And we're going to begin by getting into one of the most important parts of JavaScript, and that is the function. So we've already kind of seen functions just a bit in chapter 2, and I described them then as a bunch of lines of JavaScript that are related, that are kind of wrapped together. And that's a nice simple way to think about it, but a function is a lot more. Think about a function as if it's a black box. You can pass some values into it, and you get a value out of it, but you can't control what's going on inside of it when you're using it. People can build the black box, and you can build functions too, where you decide what they do, but after they've been built, or while you're using them, you can't adjust how they work. You just hand them a value, and they hand you a value back. So there are a number of lines of code, or as much code as you want really, can be put inside of a function. But when you create a function, the code isn't run right away. It's almost like it's put in a variable. You give the function a name, and you say, hold these lines of code for me. When I want to run these lines of code, I'll call you, and you'll do the work for me. So if you need to use the same set of lines of code in several places, that's one of the places a function comes in very handy. So let's before we actually start writing functions, I want to point out two things that are specific to functions in JavaScript. Every language has functions, but functions in JavaScript are objects. We've seen in chapter 2 how to create an object literal with the curly brace notation with your key value pairs inside. We can't create a function in the same way. However, functions can have properties, as we've seen a bit, that objects can have, and they can also have methods, which we'll discuss further on in this tutorial. And we'll look at how to use these. But functions are real JavaScript objects. The other thing is that functions are like any other JavaScript value. In many programming languages, a function is something different from a value like a string or a number or something like that. However, in JavaScript, functions are the same thing as a string or a number in that they are values that you can pass around and use in the very same way you would use a string or a number. So enough with the theory, let's actually look at some functions. So as we've had before, I have a little HTML file here that just links to our chapter 3.js JavaScript file, and in here we will begin looking at functions. So how do we create a function? We start with the keyword function, and then we have the function's name. Let's just call this function say hi. Next, we put parentheses, and we'll see how to use these more in a bit. And then we have an opening curly brace and a closing curly brace. And usually those curly braces are put on separate lines because we're going to have a number of lines of code that go inside the function. Now, any of the code that you've learned so far can go inside a function just as well as out. So for example, let's run or write the code alert hello. Remember, we don't really know what alert does yet or how this works, but hopefully you're starting to get a little bit of an intuition of what's going on, and we'll see this in a minute more. So alright, so we've got that written there. Let's pop open Firefox here. We have the file open here. If I refresh this page, we don't get anything. Why not? Well, remember I said that a function encapsulates or holds a bunch of code. In this case, it's only one line, but it doesn't run that code right away. It's almost like a variable where we say, hold this, when we need it, we'll call you. So if you were to think about this function as a variable, say hi is the variable name, and it refers to all the lines of code that are in here. So how do we use the variable? Or more correctly, how do we call the function? Well, we do it by using the function's name and then putting a set of parentheses after it, just like that. This says run all the lines of code that are in the function that is called say hi. Now if I come back here and refresh the page, you see that we get this alert box, hello. So that's pretty simple. But let's take this a little bit further. These parentheses here can actually take a number of parameters. Remember how I said a function is like a black box that you can pass values into and receive a value out of. Inside these parentheses, we define what values you can pass into the function. What we do is, well, first let me show you how we would pass them in. So basically, inside these parentheses, we just write any values. They can be referenced from variables or whatever, but we just pass as many values as we want to hand into the function, each one separated by a comma, similar to an array. So what we can do here is let's just pass in the single string Andrew right now. All right, so we have the spaces on the outside there. Doesn't matter. You can add those spaces or not if you want. Most of the time a space does not matter in JavaScript. So we're handing it a value. Now, how do we know how we reference that value from inside the function? Well, that's what we put up in this set of parameters. So right now I'll put name. And this is very similar to a normal variable. Name here, when we call the say hi function, the first parameter that we pass into say hi will be assigned to the first parameter that we have up here. So it's almost like this variable name will receive the value Andrew. So now let's change this to say alert. And then we'll put the name variable just like that. And I'll let me add a exclamation point to the end of that. And so now let's see how this works here. If I come here and refresh the page, you can see we have hello Andrew. So notice what's going on. We're passing a value into the say hi function, and we're receiving hello Andrew exclamation point out of the function. But we don't have any control over that. We can pass in different names here. For example, I could change this name to Bob. Rerun this, and we get hello Bob. I could change it to another name, for example, Gwendolyn. I don't know if I spelled that right. And we could get Gwendolyn, and we could get hello Gwendolyn, just like that. Now, a function can just as easily take more than one parameter. I could say, we could just call this person1 and person2, just like that. And now we can take two things here, Gwendolyn and let's say Alexi, just like that. And now we'll use those in here differently. So we can say person1 plus and plus person2. So notice what we're doing now is we're making this function accept two parameters, and we're passing it two parameters. Parameters can also be called arguments. And then we're just using them both here in the alert. And now when I refresh this, we get hello Gwendolyn and Alexi. Excellent. Now let me tell you one more thing about parameters here. And that is that we don't have to use all the parameters that this function gets passed. So for example, let's say we only want to use one, but we're still passing two to the function. So what's going to happen to the second parameter, Alexi? Let me refresh this. We just get hello Gwendolyn. No error is thrown. For right now, we're just losing this second parameter. It gets passed in, but it doesn't actually exist. We'll see more about this later, but for right now, realize that the way we're doing this, there's no way to access that second parameter from inside the function. So the user of your function, which is usually going to be you, but remember, JavaScript has many libraries and stuff like that, so you may be using other people's code or other people may be using your code. So it's good to think about that when you're writing your code. However, the user of the function, the user of our say hi function, only wrote the function to work with one parameter. We can pass as many parameters as we want in, but it's only going to use the first one. And JavaScript will not complain no matter how many we pass in. Let's change this up a bit now, because I want to talk about returning values from a function. Currently, what we're doing is alerting a value out. But that's not always useful. Let's say we want to take that value and do something with it outside the function. For example, we could want to log it to the console, or we might want to alert it, but we just want to get the message that the function gives us. The way we do this is by returning a value from the function. Notice I've changed the alert here and instead put the keyword return in front of the string that this is creating. This code here creates a string. It concatenates a string that gets passed in as a parameter, and then a string with the exclamation point into a single string. And that is what's going to get returned from this function. When the function sees the value return, it will return whatever is after the return keyword to the code that called the function. and then the function stops executing. So any code that would come after this return statement would not get executed. So you might think, well, why would you have code after a return statement? Well, think back to the if statements we were using earlier. Let's say you wanted to return a different thing from the function depending on the parameter that gets passed in. In the examples for this section in the book, this is exactly what we do. Well, you could have the return keyword inside of the if statement. You could have a return keyword inside of the else statement. And the else statement comes after the return keyword in the if statement, but that doesn't get executed. Now, because it's in an if statement, it wouldn't get executed anyway. But the point is that you can return from different points in the function depending on how you want the control to flow. And you can look at this section in the book for more detail on that. But so where does this return value go? So if I refresh this page right now, we don't get any values in the console or in alert boxes. What we need to do is capture that value that's getting returned. And if you think about it for a second, hopefully you can come up with the right answer. The right answer is that we have to put it in a variable or do something with it right away. So for example, I could say var message equals and call the function. When this function gets called, the value that is returned will be stored in the variable message. And now I can alert the message. And now we get hello Gwendolyn, just like you would expect. Side note here, now you should understand what we've been doing when we've used this alert box, when we've used this alert code previously. Can you see that alert is a function and that message is a single parameter that we're passing to it? This is a function that the browser provides for us. And see how it's a black box. We can't control what goes on inside alert. We don't even know what goes on inside of the alert function. But somewhere in the browser's code, there's code that looks something like this. Alert message. And in here, it creates the alert box, right? And you can see how that would work. So we are calling the alert function here, which in turn pops up this checkbox, or I'm sorry, this alert box that we've been seeing all the way along. Similar is the case of console.log. If I console.log this message just like this, you can see that we have hello Gwendolyn output to the console here. Think about this for a second. Remember how we saw when we had an array, let's say ARR is an array in this case, and we could use the length property? We saw how that would equal something in an object, or where if we create an object, like we could have person.name equals Joe or something like that. We saw how we can we can access properties on an object via the dot notation. But then remember that we just said that functions are the same type, are values in JavaScript, just like those other value types that we were assigning to properties. This means that we can assign a function as a property on an object as well. When we have a function assigned on a property, it's called a method, and that's exactly what the log function here is on the console object. You can imagine this looking something like this, where we have log equals function with the message getting passed in like that, right? And then in here, it logs the message to the console. So now this code that we've been using in our examples that you haven't really understood, you should understand how it works right now. So let's go back to our functions here. Let's talk about these arguments or parameters that we've been using. Let's go back to those. Remember how we said that if we pass in a second one, like Alexi here as we did before, it would just kind of get lost here in the say hi function. The truth is it doesn't actually get lost. It's held somewhere else for us. So let's look at something else here. I'm going to bring up a different example. Let's do this. Let's say we want to have a function that can take any number of parameters. Those parameters will be numbers, and it will just add up all the numbers that we pass in. We're making a sum function. Well, what we could do, or think about how you might do this. It might not seem completely obvious at first. How can we have an indefinite number of parameters? Well, this is how we can do it. Oh, you're probably wondering, what did he just do there? He didn't give the function a name like he should have, like he did before, and he assigned it to a variable instead. Yes, you can do this. You can decide not to give a function a name. In that case, it's called an anonymous function, is a popular name for it. And then assign it to a variable. Now for this function, we'll call it using the variable name because the function itself doesn't have a name. And that's perfectly valid. We're going to come back to these semicolons in a minute, but first let's talk about what I've just been distracted from here, and that is our arguments. So there's an arguments object that you have access to from inside every function, which is an object that's very similar to an array in that it has parameters. It's very similar to an array in that it has properties that are have numbers as their key instead of a word. So it's more like it has an index, and then it also has the length property. Apart from that, it's an object that's not really like an array, but it has a few array properties that allow us to treat it a bit like an array, as you'll see. So this this arguments object is available to us inside the function, and it's an object that contains all the parameters that were passed into this function. So let's do this. Let's call sum here, and we'll pass in the parameters 1, 2, 3, 4, and 5. And then in here, let's just console.log arguments to see what arguments the arguments object equals inside this function. So if I refresh this page, you can see we have what looks like an array here in the console, and it's just the numbers 1, 2, 3, 4, and 5. So it's, for our purposes, it's an array with the numbers that we pass in. I can change this up here. Do something like that. If I refresh the page, you can see it has the added numbers. So whatever call, let's do this. Let's do another call here. Let's do 90, 45, 67, 12, 32, 43. You can see we're getting another array here of the numbers that we pass into this function. All right, so can you think of what we would have to do to return a value that is the sum of all these numbers? Well, what we have to do is we have to keep a total value, a variable that's going to equal 0 to start with. Let's also create an I variable. Hopefully you can see where we're going with this. We're going to set I to equal 0. We're going to open a for loop here. Then we'll say, well, I is less than arguments.length, I plus plus. So if you haven't been practicing your JavaScript, and then you haven't seen this for loop since our last screencast. So remember, the way this works is that we have some code at the beginning here that initializes any variables we'll need for this for loop. In this case, we're setting I equal to 0. The second section here is the condition that if it's true, the loop will repeat one more time, or it will repeat again. Before the loop is executed, it will check this condition to see if it's still true. If it is true, it will run the loop. Then, after each loop, we have the index incrementer, so that I will be incremented. So basically, we're stepping through each item in the arguments array here. So what we're going to do is say total equals total. So total equals whatever is currently in total plus arguments I. So think of what this is going to do. Assume that arguments is what we have here in the first case. I is going to be 0. Arguments dot length is going to be 1, 2, 3. It's going to be 5, 6, 7, 8 in this case. So 0 is less than 8. So total equals 0. We're going to set total to equal 0 plus 1 because arguments at the 0 index is 1. So 0 plus 1 is 1. Total will now equal 1. When we come through this the second time, total will equal 1. Arguments I, which will be 1, this argument at index 1 is 2. 1 plus 2 is 3. It'll equal 3. Next time we'll add 3 to 3 to make it 6. Next time we'll add 6 to 4 to make it 10. And we'll keep doing that. Once the loop exits for the last time, or once the loop runs for the last time, the argument will and we'll increment I from 7, which will be the index of the final parameter here. We'll increment it to 8. 8 is no longer less than 8, so the for loop will no longer run. We'll return to the, or we'll continue on to the code after the for loop. Here, we're just going to return total. Hopefully you can see how this works. We set up some variables here. We run the for loop to one by one add each variable to our total, and then we return the total. So in this case, let's alert the sum. Whoops. Let's alert the sum here. And let's do the same thing down here. We get 750 and 289. That looks good to me. What we can do just to make sure we're getting that right is let's just copy these, paste it down here, oops, in the Firebug console, and then I'm just going to replace each of those commas with a plus sign. And you can see we do get 750, which is just what we got when we refresh the page there, 750. We won't do the other one. We can be pretty sure that's right. So there's a quick look at how we can use the arguments object. Now remember, because it's not an array, we can't have any of the other properties of an array, which we haven't looked at yet, but we're going to get to those pretty soon here. But basically you can use length and you can access each of the properties with a numerical index. And that's what you can do with that arguments object. All right, let's move on to another function related topic, which is very important. That is scope. We've mentioned scope in passing a bit, but we're going to discuss it in a bit more detail now. When I talk about scope, it's basically the set of variables that you have access to at the current time in your code. So when we're just writing, let's just variable name equals Bob, just like that. Okay? That is a global variable because it's not inside a function of any kind. It's available anywhere within this JavaScript file. And I'm not sure if I've mentioned this or not yet, but we can link up multiple scripts, of course, in here. And any variables that are global within one file can be accessed within any code in another file. So if I were to, let me see, if I were to just link up, let's say, chapter 5.js and chapter 5.js called a global variable, used a global variable called name, it would actually be accessing this global variable here in chapter 3. So basically think of it like this. Although you break your JavaScript into separate files, when the browser runs it, it clumps them all into one big chunk. So they're no longer in separate files, and any global variable is accessible from anywhere in any JavaScript being run on the page. That's why it's called global. So if a variable is not inside a function, it's a global variable, and it's accessible from everywhere. That's what we've got right here. You might think this is a good idea, but we'll see why global variables are emphatically a bad thing, and we'll talk about that in the next chapter. But for now, realize that the scope of this variable is global, which means it can be accessed from everywhere. So let's create a function here that we're just going to call, let's call it greet. It's going to take one parameter, which is a greeting. Inside this function here, we're going to have a variable called, actually, we're not going to have a variable. We're going to return greeting plus space plus name. So it's a very simple function. Now, let's talk about something here. So we have this function here that's going to take a greeting. Let's just use it here. So let's just alert greet, and we'll just say hello. Notice how I can nest a function call in as a parameter of a function. You've already seen that, I think, but I don't think I mentioned it. Remember, greet hello is just going to return a string, and that string is then used as the parameter for alert. So if I alert this here, you can see we get hello Bob, just what you would expect. But let's talk about this in relation to scope. So inside this function here, we can access the global variable, because remember, the global variable can be accessed from anywhere in the code, including inside of a function. Greeting here is a parameter, which is kind of like a variable that we set inside the function. For example, I could have set var something else here, right? Just like that. you could consider both parameters and variables inside the function have the same scope. The scope of these variables, first of all, a variable created in there could be called a local variable because it's created inside the function and it is local to the function. So parameters and local variables can only be used from inside the function they are created in. That's their scope. And really, if you boil it all down, scope is just that easy. Any global variable can be accessed from anywhere. Any local variable or parameter created inside of a function can only be used inside that function. It's that simple in JavaScript. In other languages, scope is a bit more complex, but in JavaScript, it's that easy. I'll mention something here. Let's look at this. Okay, pause right here. Yes, you can put functions inside of functions because functions are just a normal value, and if we can use strings inside of a function, we can use functions inside of a function. So here, we're going to return I'm using the conditional operator. If greeting equals hello, we're going to return an exclamation mark. Otherwise, we're going to return a period. So again, a very simple function that depending on what greeting is, now greeting, this is this greeting up here. I thought that I said you can only use local variables and parameters from inside the function that they were created in. Yes, but this function is inside of that function, and so they have access to them too. Now, if I were to do something like this, say exclamation mark equals that and period equals that. This is obviously not a smart thing to do, but if I were to do this, and let me change this to say E or P, depending on what we want, these variables E and P can only be accessed from inside of their scope, or inside of the function that they were created in. That is their scope. Greeting can be accessed from inside of the function that it was created in, which includes this function in here. Name can be accessed from anywhere because it's a global variable. All right, so I hope you're getting the idea of scope here. Scope is basically the idea that a variable can only be accessed from either the global namespace. A namespace is just a fancy word for area. So the global area, if it's created outside of a function, or inside of the function it was created in, whether it's a local variable or a parameter. Now, let's throw a curveball here. Look at that. We just created a local variable inside the greeting function called name. Now, what's going to happen? Well, first of all, let me use getPunk here. When I refresh the page here, we get hello Alice instead of hello Bob, as we were getting before. Notice if I comment this line out, we get hello Bob. If I uncomment that line, we get hello Alice. What's the difference here? Well, basically, by having a local variable with the name Alice, with the name, we're overriding our ability to access a global variable with that name. What you can see here is that when there's a conflict like this, local values get precedence. So in here, there's no way to refer to our variable here, Bob. Well, actually, there is another way, but we'll get to that in the next chapter. But basically, what you could just do is say this dot name. If I do that, then you can see we'll get Bob. You'll understand what this does when we move on to the next chapter. Window.name works as well. All right. So that'll whet your appetite for the next chapter. However, right now, let's go back to talking about functions. Now remember, we had a function. When we did the sum function, I did this. Two things here. First of all, semicolons. Let's talk about semicolons. We talked about semicolons in the previous chapter. but let's revisit them here. I basically said that any line of code, that almost any line of code should end with a semicolon, except lines that have curly braces. For example, in an if statement, like this, any line of code that goes in here, inside the if statement, should end with a semicolon. However, the lines that end in the curly braces that denote the block should not end with a semicolon, because they are denoting a block. All right. Now, that same thing goes for a while loop and a for loop. We saw when we have a for loop, right? We saw how we require the semicolons in here, and technically semicolons are going after each expression. An expression is something that returns value, and because a for block, like a for statement like this, is not an expression, it does not return a value. We do not put a semicolon after it. Same thing goes for functions. When I create a new function like this, I do not put a semicolon at the end of this line, and do not put a semicolon at the end of this line. When I create a new object, literal, right? If I have an object literal like this, name equals Joe, then I could be assigning to a variable like this. I do put a semicolon at the end of this, because this line here, see, you could think of it as one line, because it could be written as one line like this. And of course you could say, well, you could put a whole for statement on one line or whatever. Yes, you could, but think of it like this. This part here returns a value. It's an expression because it returns a value. We're setting something here. Object gets a value here, and that's why it has a semicolon at the end of it. In this case, it's the same thing. Function sum does not return a value. However, when I assigning it to a variable, suddenly we are returning a value, and we're assigning that to the variable sum. Therefore, it should have a semicolon at the end of it. That's why I just put that semicolon there. But there's another thing that I want to talk about besides semicolons that has to do with this, and that is that this function does not have a name. I mentioned that it doesn't have a name, and I said that we can call it an anonymous function. Now, you saw that an anonymous function could be called via assigning it to a variable name, and that works well. However, there's something else we can do here. We don't always assign anonymous functions to variable names. For example, an anonymous function might be a parameter to another function. You'll find this very often, especially in JavaScript libraries, where they'll have a function. For example, if we have a function called for each, as just an example, and then what they'll do is you'll pass a function like this. Notice how we have a function here. It's just a small function that I'm putting on one line, passing it as a parameter to the for each method. Notice that it's taking a parameter too. This function that I'm passing takes a parameter. That parameter will be given to this function as a parameter when it's called. For example, if we were to kind of guess what might be inside this for each function, it might look like this. We could use fn as an abbreviation for function. And then it's really this easy. We can call the function. Remember, because this function here, it's an anonymous function, but it gets passed into a parameter. The parameter has a name, and then fn here is our parameter name. It refers to this anonymous function. And then we can call it passing it in a value, just like that. So if I were to, I'm just going to move this down here. Hint here, the reason my JavaScript little debugging thing was complaining there was because this function was written after it was called. And although this will work in JavaScript, it's a good idea to write them before you use them. So now if I refresh this page, you'll see we get an alert here saying some value. That's because we're running a function, passing it a function as a parameter. This function takes that function as a parameter and calls the function we passed in, which runs this function down here. I becomes the string some value, and we just alert I, and then we get some value there. So that is another place where anonymous functions are useful. Let's look at one more place where an anonymous function is useful. Okay, this looks kind of weird, but we're only doing two things differently than we normally do when we run a function. First of all, we're putting parentheses around the whole thing. You can see this parentheses matching the one at the first one matching the last one. The second thing is you can see we are calling the function right away by putting those parentheses at the end of it. Normally, we would give the function a name, for example, sum, and then put the parentheses after the name when we call it separate from the function. However, this is a common way of writing a bunch of code, putting it all inside of a function, and running it right away. Why would you do this? Well, you would do it for a number of reasons. We're going to discuss the main reason to do that, which is closure. We'll discuss that in the next chapter. However, another reason you might do it is just to encapsulate all your code so that you're not using any global variables. Remember, we said that global variables are a bad idea. I'll tell you more about why global variables are a bad idea in the next chapter, and we'll revisit this topic. But basically, if I set our name variable in here, like that, it's not accessible from out here. Notice if I do a console.log name, it's not this value of name inside the function here. Now, in here, if I do console.log name, you can see we get Bob. Now remember, because this function is being called right away, it's actually getting run, but it's keeping any values that we have inside that function encapsulated. We'll talk more about anonymous functions later. But for now, I want to talk about type methods. We mentioned earlier that a method is just a function that's being used as a parameter, as a property in an object. And there are many methods on the values that we've already discussed. For example, string, number, date, normal objects, that kind of thing. They all have built-in methods that you can use. And we're going to discuss those now. This might get kind of dull, but the point is to get you used to all of the different type methods that you're going to be using while you're working with these values. So let's begin with strings. So we have a string here. Let's create the string. We'll just use, let's say getting good with JavaScript is a string. So I can alert that out as a string just like that. Now, to use a method, remember, as we've seen before, we use the dot method name, or we use the dot method name syntax. In this case, we're going to use length as the first method we're going to learn. Actually, length isn't a method, it's a property, but we're going to be learning mostly methods here. I'm throwing in this property because it's an important one here for strings. So this is going to give us the length of the string. If we refresh the page, you can see that the alert says 28, which is the number of characters in the string here. If I was going to go ahead and count it, I'm sure I'd find that we get 28. Now, notice that we don't have to put them right off the actual string literal just like that. I could put the string in a variable like this and say title.length, and we still get 28. So realize that this works whether you were working with object or value literals, for example, the actual number or the actual string, or whether we're working with the values put into a variable. JavaScript views both of those as the very same thing. So length just tells you the number of characters in a string. Let's talk about something else. How about searching inside of a string? So let's search for the word good inside this string. Well, the way we use this is by using the index of method. The index of method will return the index of the place where whatever parameter we pass it begins in the string. So if we pass it good here, what it's going to do is it's going to search through this string, see if it can find the word good. If it finds good, it's going to pass us the index where that word good starts. So in this case, we're going to get, now remember indexes are 0 based in JavaScript, so we're going to get 0, 1, 2, 3, 4, 5, 6, 7, 8. In the 8th index is where the string that we searched for begins. So we can expect to get an alert of 8. If I refresh this page, you can see that we do indeed get the number 8. What would happen if we search for something that is not in the string? So for example, if we change this and search for the word get, if I refresh the page, we get -1. If 0 is the very first one, -1 means before the first, or basically it's not in the string. You'll see a lot of methods that do that. When they return an index in, when you return an index from either a string or an array, if whatever you were trying to return the index of does not exist, it will return -1. Okay, so that's searching within a string. How about slicing up a string? Well, there are 3 methods that you can use to slice up a string. The first one is slice. So let's say title.slice. What parameters do we pass to slice? The first parameter is going to be the starting index of where we slice, and the second parameter is going to be the ending index of where we slice. So let's say we wanted to just slice the word, we'll say getting. So we want to begin at 0, and we want to end at, let's see, 0, 1, 2, 3, 4, 5, 6. 6 is going to be the last letter, but what we want, the index 6 is going to be the last character that we want in the string, but we have to give it the one after. So basically we give the first one and the one after the last one. So we'll say 7 here. 7. So let me console.log this. Just like that. And if I refresh this, you can see that we get the word getting put out. So that shows us how to just get a single thing from the word, get a single word out of a string like that. We can use slice. You can also do in a negative way. I could use -1, which refers to the last character in the string, and I can use, let's say, -10, which refers to the 10th index if we're counting from the back. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, it's going to cut off right at the J, and we're just going to get JavaScript because we're going from -1 to -10. If I refresh the page here, you can see, whoops, okay, we're getting an empty string. Let's see, what did I do wrong? Oh, I think the problem is that I have to actually put the -10 first. So it's not actually doing the cut backwards. It's going to, so for example, if I do that, yes, you can say, okay, we get JavaScript. And you can see what it's doing is, so -1 refers to the last character. -10 is it's going from the J and it's cutting this way. So it doesn't actually cut backwards, it's cutting forward still. But we can use the negative parameters to count in from the back. So we're saying count back -10 and then cut up until -1. So that's why we're getting JavaScript that way. We could also leave off the last parameter, whether we're using positive or negative, and that will just cut from wherever the first parameter here is right up to the end of the string. So now if I refresh this, you can see we're getting the whole word JavaScript. So that's how slice works. The next one is subster. Let me, let's just start over here. So we can have title.subster. And subster, you might wonder why not call it substring. Well, that's because the next one here is going to be substring. And we're going to come to that one in a second. But subster works a bit differently from substring. With subster, the first parameter is the same as slice. It's the starting index. So in this case, let's use the starting index of 9. The second one, instead of being the ending index, it is the length of the substring. So let's say we want to start at index 9 and we want to get 4 characters. So now if I refresh the page here, oops, I have to say console.log to this. We get the word ood, almost all of good. So we started at 9, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's change this then to 8. And now you can see we started at good. We started G and get G-O-O-D. Now you might wonder, how come when we started at 9 we only got 3 characters instead of 4? Well, we actually got 4. We got 1, 2, 3, 4. We got the space, so that's how we couldn't see it. But now we have 8 visible characters there. I'm sorry, we have 4 visible characters. So we start at the first parameter is the starting index, and the second one is the length of the substring. Now we can't use negatives. We obviously can't have a negative length in the string, so we can't use a negative number for the second parameter, but we can use a negative number for the first parameter. So if we want to say, let's say we started at -8 and go for 4, we get VACS. So it started at -8 and went for 4. And of course, the second parameter is optional if we want the rest of the string. And if we leave the second parameter off, this is just going to work the same way that slice did. All right, so now we have one more here, substring. So substring works very similarly to slice, except when you're using negative values. A negative value for each parameter acts as 0. Now remember how I had the problem with slice with the first parameter when I used -1 and -10 as the parameter. I couldn't have that because -1 was later in the string than -10. Substring doesn't have this problem. So for example, well, let me show you here. If I was going to use slice, and let's say I was going to say slice from 5 to 3. If I console.log that with slice, we get an empty string because I can't go from 0, 1, 2, 3, 4, 5, the n, back to 3. It doesn't work that way. It only cuts forward. However, if I change this to, substring, this will work now, because what happens is substring will go back to the character of that index. So it's going to say start at 5 and cut back to 3. So now if I refresh this, it started at 5, which is n, and cuts back 2 spaces to 3. Now remember, 5 as the starting point, because it's actually become the ending point, it begins, well, the actual characters we see begin at 4, so we actually only get 3 and 4 as the characters we actually see, or that are actually in our substring. However, we can put a greater value as the first parameter, and a lesser value as the second parameter when we use substring. All right, a few more methods here. Next one is split, and that just what the split method does is it takes a single parameter, and that parameter is going to be a character that we split the string on. So let's pass it a space and see what we get in the console. If we refresh the page here, you can see we have getting good with get as an array. What it's done is it's split the string. Every space there's a space. Every place there is the character we passed in, which is a space in this case. So space, space, and space. It's been split at those spots. The spaces have been taken out, and we get an array. If I change this character to a G, you can see we're split before the first G. So we split before the first G is actually one place in the array where there's no characters. We get ETTIN here. We split at G here, so we have an empty space between the two G's because we split at this G, and then we get the rest of the string here as one spot. So notice we have a blank string here and a string with a single space in it here, but we have split on the G's. So that's, remember how I said earlier, if you want to take a string and split it into an array, this is how we would do that. All right. Next one is going to be very obvious. Title dot to lowercase. Now the title already is in lowercase, so what I'm just going to do here is put the word JavaScript in full caps. And now if we refresh the page, you see we're getting the title, and it's completely in lowercase. To a lowercase just changes the string to all lowercase values. I bet you can get what to uppercase does. That's right, it puts all the values, all the characters in the string to uppercase. Very simple. All right, well, those are all the methods we're going to look at for strings. Let's move on to numbers. So let's create a value here. Well, so the first method we're going to look at is to exponential. So if I have a variable here that's just 1, 2, 3, 4, 5 as a number, whoops, we want to say, we'll just say num. So let's console.log num.to exponential. Hopefully I've spelled that right. Let's see what happens. If I refresh the page, we get 1.2345 e plus 4. So you remember when we talked about numbers, we talked about how we could use exponential notation. Basically, this will just take whatever number you're handing it and convert it to exponential notation. I should note that this output here is actually a string. For example, if I do type of there, you can see that we are getting a string out of this. And all of the number methods actually return a string. However, the good thing to know is that because they are all number string, well, we'll discuss what you can do to fix this in a second here, to turn them back into numbers. But the point is that these are formatting things. We're taking a number, and because JavaScript doesn't care whether the number is 1, 2, 3, 4, 5 or 1.2345 times 10 to the power of 4 or whatever it was, JavaScript shows those numbers the same way. But if you want to output these numbers in a given way, this is what these are for. So we have two exponential. Let's show another one here, which is num dot to fixed. To fixed will take a number as its parameter, and it will round your number to that digit. So if I add a couple of decimal points here, let's say we want this to be fixed to 2 digits. If I refresh the page here, you can see that this is fixed to 12345.68. So it does round. It's not just cutting off at 7. Cutting it off at 7, it's actually rounding up to 0.68. If we don't pass any values to fixed, it will round it right to 0 decimal points. So let's just leave that as 2 decimal points for now. Finally, we have to precision. So let's say num dot to precision, and as a parameter, well, let's not pass it anything as a parameter to begin with. When we don't pass it anything as a parameter, we see nothing actually happens to the number. To precision just decides how many digits should represent your number. So for example, if I was going to say, let's say we want 6 digits to represent this number, notice that it rounds it right up to there. However, if I was going to say I only want 4 digits to represent this number, it's giving us 1.235 times e to the power of 4. So it's saying 1.235 is the way, because we've said we want only 4 digits, those are the 4 digits it gives us. So it's kind of quirky in that way, but you can see how it's giving us 4 digits. So it's giving us precision up to 4 digits is what it is. Now, as I mentioned, all of these are strings. As you can see, if I was to go ahead and do give us the type of the output for each of these, you will see that the type of the output is string for all of them. So how can we convert those strings back into numbers? Well, what I can do is very simply with the built-in method parseInt. This is a built-in JavaScript function. And now this should just log out a number. And this is logging out the number 1. So let's see. Well, let's do this first. Let's paste this here. We'll take out this call to parseInt so we can see what's actually going on. So notice when we put num to exponential, it's doing 1 point, etc. there, to the power of 4. That's a string. What parseInt does is it begins at the beginning of the string, and it goes until it sees something that does not look like an int. Now, int stands for integer, which basically means a whole number. So it will get the 1, and then it'll see this decimal sign, and it'll say, well, that's not a number, so we stop there. For example here, let's just do an example here where we have parseInt if the string was 1, 2, 3, 4, 5, or just say 1, 2, 3, ABC, like that, you can see we get 123 as our value out of it. So that's what it was able to parse out of that string. Now what if instead of parseInt we used parsefloat? Parsefloat can do a bit more than parseInt in that it accepts decimals. However, I think it may choke on the exponential notation. Let's see. No, it did just fine, so that's good. So notice how it actually converted, it understood the decimal notation. It just didn't get the 1 out that the parseInt did. It actually understood this is in exponential notation and converted it back to the very same number that we started with. So if you have numbers that require decimal points, you're going to want to use parsefloat instead of parseInt. Okay, those are the number methods. Let's move on to date methods. So let me create a date object here. var today equals new date. Oh, you know what? I just thought of something that I want to show you with number methods. So let's, for example, say to fixed. So we have a method here, let's say a number 10. If I say dot 10 dot to fix, now remember, because these are, and we're going to say to fixed, we'll tell it to fix it to 3 decimal places. Now, remember, because we can just use literal values like this and put the methods on there, you'd think we could do this. But if we refresh the page, you'll see we get an error. Identifier starts immediately after numeric literal. What does that mean? Basically, it's this. 10, and then we have the dot. The JavaScript engine assumes that that dot means we want, it's a decimal point. We're going to do something like 10.3 or 10.3 or something like that, and it's just going to be a normal decimal value. However, that's not what we're doing, and so we can confuse it. What we could do is just put 10.0 like that, refresh it like that, and you can see we're not getting, well, let me console.log this so that if there's no error, we're still going to get a value. You see we get 10 fixed to 3 decimal places like that. The other thing to do is just to put 2 periods, just like that. It looks awkward, but it's perfectly fine. And we get 10 just like that. So 10 dot dot. The first one's the decimal dot. The second one is the dot to call the method. So just keep that in mind if you're calling number methods off number literals. Okay, so back to dates. There are a whole bunch of date methods, and I think this is going to be best just showing you if I do this right within the console here. So if I refresh this page, and notice because this is a global variable, I have access to it everywhere, including in the Firebug console. So I could just call today, and you see that we get this today method, or that we get this date right there. Oops. All right, so let's look at some of the methods here. First, we could do today.getDate, and we get 21, which is the day that I'm recording this. That's the day of the month. It's June 21st. We can do today.getDay, and that gets 2, which is the day of the week with a 0 index. So today is a Tuesday, so Sunday being 0, Monday being 1, Tuesday being 2. So we get the day of the week in that way. All right, we can do get full year. Yes, I'm doing this in 2011. We can do get hours, and it is indeed the 23rd hour, which is 11 p.m. We can do get milliseconds, and that is the milliseconds that the millisecond that this date object was created. We can do get minutes. This date object was created at the 20th minute in the 23rd hour. We can do get month. Get month 5. Now remember, month 2 is 0 based. This is June, so it's actually the 6th month of the year. But because January is 0, June is going to be 5. That's good. After month, we can do get seconds. 24 second, that's fine. We can do get time. Whoa, what is that? So basically, that is the number of milliseconds since January 1st, 1970. That's the Unix epoch. And you can look that up on Wikipedia. There's an article, link to the Wikipedia article in the book. But basically, it's when they decided that computers would, all computers are when they count time. We can count time specifically by counting the number of milliseconds from January 1st, 1970. Finally, one more. We can get time zone offset. And whoops, I need to actually put the parentheses there to actually call the function. And you can see that we get 240, which is the difference between a Greenwich Mean Time and my local time in minutes. So I know that Greenwich Mean Time is 240 minutes ahead of me, and I can actually divide this by 60 to see that right now I am 4 hours behind Greenwich Mean Time. All right, now most of these can have the set values as well, so I can do set date, set full year, set hours, set milliseconds, set minutes, set month, set seconds, and set time. Really, set time zone. Offset is the only one that I cannot set. So if I was just going to show you one of those, for example, So you can see that this is the date today, and we're not going to go through them all, but if I do today dot, let's do set date, I'm going to pass in, let's pass in 25. And you can see that we get the epoch time back, but if I now say today, you can see that now date is Saturday, June 25th instead of Tuesday, June 21st. So I can customize the date like that. Let's do a today dot set hour. Set hours, we'll set it to 4 instead of 23. And now when I run today, you can see that this here is Saturday, June 25th at 4 in the morning instead of 23 at night. So there you go. Those are the date methods. Now, there's actually also a date method on the actual date function. So this is date parse. And what this basically does is you can pass it a string date, and it will try its best to convert it to a date. So, for example, we could say, let's just say June 23rd, 2011. Let's say 5:30. If I pass that as a string, let's alert what comes out of that method. Actually, no, let's do a console.log. If I refresh this, you can see that we get a huge number. That's the number, a millisecond number. So what I can do then is just say new date, and I can use that as the parameter for the new date. And now we get Thursday, June 23rd. There you go, which is exactly what we expect. 5:30. Yep, it even got the 5:30 part. There you go. So date.parse can take a string date, and it will do its best to parse it. It's not always going to work, but it'll do what it can. All right, let's move on to talk about arrays. So let's create an array here. I'm just going to create an array with a bunch of pets here. So we're going to say cats, dogs, hamsters, fish. Nothing too complicated. So we have an array there. Let's see what we can do. Well, first of all, console.log, we can do array.join. This is kind of the opposite of string.split. Array.join is just going to join all of these items here, and whatever we pass in here as the parameter is going to be what joins them. So we're going to have to say put a space between each of these. So if I refresh this, you can see we get cats, dogs, hamsters, and fish. I could do something a little more fancy and do something like that, and we get that between each of the values that are in the array. That's array.join. It's pretty simple. We can also do array.pop and array.shift. So array.pop takes a value off the beginning of the array. So let's do this. Let's console.log array.pop and then console.log the array itself. So array.pop will pop a value off the end of the array and return it. So this first line here should return fish in the console. But it's popping it off the array, which means it's actually removing the item from the array. So when we log the array down here, we should only have cats, dogs, and hamsters. Let's see if that works. Indeed, we do get fish out there and cats, dogs, and hamsters as the array in there. Let's keep going on here with array.shift. Array.shift is going to take an object, or I'm sorry, take an item off the beginning of the array. So now this should take cats off the beginning of the array, and when we log the array down here, we should just have dogs and hamsters left. Yep, indeed, that is the case. So let's keep going with these. Next, we have push and unshift. These are the opposite of pop and shift. So if we say array push, we push a value onto the end of the array. In this case, let's say we're going to push bird onto the end of the array. And now let's log the array. So notice when we push a value onto the array, it returns the number of items that are now in the array. And we have pushed bird onto the end. Let's do console.log. We're going to do array unshift. Kind of a weird name, but array unshift adds value to the beginning. So let's see, can I think of another, we'll say rat as our final pet here, and then do console.log array. And you can see now we have 4 items in the array: rat, dogs, hamsters, and bird. So those are the ways you can add some different values to the array. There's one more, or actually another, a few more, but another one I want to just add to this example before we clear the page here, and that is array.reverse. Can you guess what that does? Rats, dogs, hamsters, bird. Here we have bird, hamsters, dogs, rat. So basically it just reverses the order of the items in the array. Pretty simple. All right, let's move on to array.slice. So let's say we have this array up here. Let's slice. It's very similar to string slice in that it takes two indices as the parameters. The first one is the starting element, and the second parameter is the index of the element after the last one you want. So if I was going to say 0 as our starting element, and let's say 3 as the item after the last one, we should just get cats, dogs, and hamsters in our array here. Let's refresh this, and indeed we just get cats, dogs, and hamsters. So it's starting at 0, slicing 0, 1, 2, and stopping at 3. So that's slicing an array. How about sorting an array? Let's say we wanted to put these items in alphabetical order. Well, we could do a console.log array.sort. Just like that. And cats, dogs, hamsters, fish. Here we have cats, dogs, fish, hamsters. So it almost was in alphabetical order, but it certainly did switch the order of fish and hamsters. Now, let's try sorting something different here. Let's say we have numbers. So for example, let's say 4, 6, 1, 9, 2, 8, 3, 5. Let's say we want to sort these numbers. Let's see, let's add 10 to the beginning there. Let me put 11 at the back here. Let's say we want to sort this. How does it do with numbers? Not so well, as you can see. We have 1, 10, 11, 2, 3, 4, 5, 6, 8, 9. Why are 10 and 11 here? Well, basically, it's sorting them as if these were letters. So 1, 1, 0, 1, 1 all come before 2. If we want to sort it as numbers, what we can do is pass a function to the sorting object. To the sorting method. And this is one of those places where we use an anonymous function as a parameter. So what does this function have to do? Well, basically this function takes two parameters. We'll just call them A and B. And what that's going to be is just two items from the array. Basically what we have to do is we have to tell it which should come first when we sort this array, A or B. If A should come before B, we return a negative number, and it will put A before B in the array. If A and B are equal, we return 0. And if B should come before A, we return a positive number. So the easy way to do this for numbers is just say return A minus B. If A is greater than B, then A should come after B. If A is greater than B, this will return a positive number, which means A should come after B. If B is greater than A, this will return a negative number, which means A should come before B. And if A and B are equal, it will return 0. So now, if we refresh this page, these numbers are in order correctly. And they're obviously, if you're sorting more complex things, for example, you could sort objects that you've created yourself. You'll need to do a more complex sorting function. And I wrote a tutorial on NetTuts a while back about sorting arrays, and you can check it out. There's a link to it in the book. All right, now JavaScript comes with a math object that you can access just by doing math. See here, if I do this in the console here, if I just say math, you can see we have an object here. Math object. It's not going to show any properties, but there are certainly some. So let's talk about some of the functions that we have because of the math that we can get via the math object. So the first one is min. We can pass it any number of parameters, and it will tell us which one is the lowest parameter. So here I'm passing 0, 5, 4, and 0.1. If I refresh this, well, let me drag this down a bit here. If I refresh the page, we can see that we get 0.1 is alerted because that is definitely the lowest value out of those parameters. There's also math.max, which returns 5 in this case, just as you would expect. There's also math.random. Math.random. And this is going to seem really random, but what it returns is a random number between 0 and 1. So it's going to be about that long, as you can see for our example here. Every time I run it, if I refresh the page, I'm going to get something different. And you might say, well, how is that even useful? If I want to get a random number, why between 0 and 1? Well, the idea is that if you have a random number between 0 and 1, then you can multiply it by something to get a number between 2 points. So if I say a random number between 0 and 1 times 10, then I get 3.7, 4.7, 8.7, 1.3, 2.6. This still doesn't seem very useful if we're trying to generate random numbers. We'll come back to this in a second, but first we have to learn a few others. For example, we want to learn round, seal, and floor. So math, let's use alert again here. Math.round basically will round any number according to the standard rounding rules that you probably learned in school. So for example, 10.4 will be rounded to 10, and 10.5 will be rounded to 11, just as you would expect. There's also math seal, EIL, which will always round up even if the decimal point is less than 5. So 10.3 does round to 11. And then there's math floor, which always rounds up even if the decimal point is 5 or above. So if I refresh this page here, whoops, I think I messed something up here with Firebug. Oh, I said math.flute. That should be math.floor. We'll round to 10, even though math.round would round this up to 11. So combining math.random with math.floor, we can actually write a function here. So we could say get random number in range, and we can take a min and a max as our parameters. And what we can do is return math.floor, which will round the number, and we can say math.random times max minus min plus 1 plus min. So this might seem rather confusing. Basically, we're saying math.floor is encircling all this. So math.floor will round the number down. So math.random gives us a random number. We're multiplying that random number by max minus min plus 1. Max minus min plus 1 basically gives us the range of numbers that we want to calculate a random number over. So for example, if the minimum number is 50 and the maximum number is 100, max minus min is going to be 50 plus 1, so we have 51. And we just add that 51 because we're always rounding down. So to make up for the fact that we're always rounding down, we don't want to get below our min, so we add 1 to make sure when we round down we keep within our min. So basically, math.random times our range will give us a random number. Then we just add that to the min to make sure it's above our min. It's going to be below our max because of this calculation here. And now this function here will return any random number between that range. So if I copy that here, let me refresh this page, and in the console, let me give this a try. So I gave the example of 50 and 100. Let's see. 64, 89, whoops, 81, 61, 68, 99. So you can see that we do get random numbers. And the random number generator that comes like math.random, it's not perfect, but it's what we have to generate random numbers with if you want to use the built-in power. All right, speaking of power, there's one more math function, and that is the power function. So math.pow will raise the first parameter to the second parameter power. So this is basically the same thing as on paper. You would write 2 to the power of 4. 2 to the power of 4, oops, we should alert that or something so we can see what it is. Oops, It looks like I just killed Firefox. Let's open this up here in Firefox. And you can see there we get 2 to the power of 4, which is 16. Well, it's been a long haul. That last section there was kind of probably boring for you, but it's important that you learn all these methods, because now you're familiar with all the data types and their methods. You understand how functions work. You understand control structures like loops and conditionals, which we discussed in the last chapter. You've got all the basics under your belt, and we can move on to discussing some more difficult techniques, and that's what we're going to do in chapter 4. See you there.